Okay, let's quickly do these ones on the board. The first question says NC9, N choose select 9 is equal to N select 8 or choose 8. Find N. From what you have done, you know that we say that NCR is equal to NC N minus R. So what does that imply? It means that R plus N minus R is equal to N. Therefore, for this above question, in this question, it means that NC9 is equal to N select 8. Therefore, N will be equal to 9 plus 8 is equal to 17. From what you have done here. So anyhow you do it. But with this, we know the fast way of solving this question. So this is the first one. Anytime you see anything like this, just equate this, the ones below, to just add the ones below, and it will be equal to the what you have selected it from. Very simple way of solving it. Now let's do the second one. It says 7C4 plus 7C5. You know, from what you have done before, we know that NCR plus NCR plus 1 is equal to N plus 1 select or choose R plus 1. So this equation here should give us 8 combination 5. Since R plus 1 is 5, R is 4. You understand? So if you try it, this one will give us 7C4 is 35. 7C5 is 21. So, and 8C5 is 56. So 35 plus 21 equals 56. So you can see, in a very simple way, we have used this to solve our problem, the properties we learned, to solve our problem without going through long way. Now let's look at this. A minibus has seats for driver and 7 passengers, as shown. When 7 passengers are seated in random order, find the probability that 2 particular passengers, A and B, are sitting on A, the same side of the minibus, B, opposite side of the minibus. Now let's look at it. A and B, if they sit on this side, or if they sit on this side, how will the arrangement be? If, and you see the driver is taking one portion, there will be 3 side positions left here. And in this place, 4 positions left for passengers. So you have total seats, 7 seats for passengers. Let's look at the arrangement will be. Let's say A and B are on the driver's side. It means that they can take any 3 positions, and there will be 5 positions left. If they are on the opposite side, there will be 4 positions for A and B, and they can take any of the 4 positions. Here there will still be 2 left for other passengers. Now let's look how it will be like. For 8 parts, if A and B are seated on the same side, that is, let's call this side A, B, no, okay, that is, let's call it driver side and opposite side of the driver. Now, since we have a conditional arrangement, let's see what the total arrangement will be. Total possible arrangements will be equal to 7p7. Now, if A and B are on the driver's side, which means that we have 3p2 because of this. 3p2 times, we now have 5 positions left for the other passengers. 5p5. You understand? That is 2 positions for A and B from the 3 side, from 3 seats, and the remaining 5 positions for the other passengers. If they are on the other opposite side, if A and B are on opposite side of the driver, the total possible arrangements will be equal to 4p2, that is 4 for A and B, and the remaining 5, after A and B are taking positions, there will still be 2 more sides on that, 2 more on this side, plus the 3 here, times 3 times 5. There will be 2 more positions there, yeah, plus 3 here, so plus 5 and 5. You can see. So, probability that they are on the same side will be equal to this one plus this one divided by this. So it's going to be 3p2 times 5p5 plus 4p2 times 5p5 divided by 7p7, because this is the total possible arrangement. Let's see what that would be like. So we are going to have 5p5 into 3p2 plus 4p2 divided by 7p7. And you know this one is going to be 5 factorial plus 7 factorial into 3p2 is 6 and 4p2 is 12. So we are going to have what's it called? 12, 18, yeah, sorry, 18 divided by 7 times 6. So we are going to have 3 over 7. So our answer is 3 over 7. So let's look at another way you can undo it. Now let's look at it from conditional situation, probability. What is the total possible arrangement for these two? Let's restrict our, let's look at it like the other 5 are not existing. Only these 2, because we are considering the position they will sit, either here or here. So let's see. So if you want to handle it that way, we will say total possible arrangements for A and B will be equal to 7p2. Now, if they are on this side alone, if on the driver's side, it will be equal to 3p2. If on the opposite side, it will be 4p2. We have now, we have restricted our concentration or attention to the 2, A and B alone. So, at the end of the day, this one does not really exist. So we are going to have probability of A and B sitting on same side will be equal to 3p2 plus 4p2 over 7p2. And this is 3 times 2. Yeah. And that's going to be 6 plus 12 over 7 times 6. That's 42. Which is 18 times 42. 6 times 3. 6 times 7. So 3 over 7. So you can see, they gave us the same answers. Now let's go to the B part. The B part says they are opposite sides of the. Let's look at. Now, the probability that they sit on opposite side of the minibus is this. Will be equal to 1 minus probability of sitting on same side. Which equals to 1 minus 3 over 7. And that is 4 over 7. So simple. Simplified. Find probability that the sum of the scores on 3 rows of an ordinary fair die is less than 5. Which means that 5 and above, they are not considered. The numbers we have less than 5 are 1, 2, 3, 4. So the least number we can have less than 5, since the least number on the die is 1. So least possible number or sum is equal to 3, which is 1 plus 1 plus 1. The other possible number less than 5. 5 is 4. And the only way we can have 4 is if we have 1, 1, and 2. That is the possible arrangement or combination. This is the possible combination for 4. So the two sums less than 5 are 3 and 4 in this equation. Total possible outcome is equal to 6 times 6 times 6. 6 raised to the power 3. Now, to find sum of 3, we are going to have 1 plus 1 plus 1. And the number of ways of getting 1 is 1 way. You can see, because if you have it as 1, 1, 1, it's going to be 3 factorial over 3 factorial. So, to find the sum of 4, we have said that the combination is 1, 1, 2. And the possible arrangements, total possible arrangement for this will be equal to 3 factorial over 2 factorial. You know, this denominator is about the similar objects. Remember, similar objects. So here we have 1, 1, that's why we have 2 factorial. Here we have 1, 1, 1, that's why we have 3 factorial here. So this is going to be 3. So, total arrangements for sum less than 5 is equal to 1 plus 3, which is equal to 4. So, probability for sum less than 5 is equal to 4 over 6 times 6 times 6. So here, 3 is equal to 1 over 9 times 6. 1 over 4. Let's look at this one as well. Find the probability that the sum of the scores on 3 rolls of an ordinary fair die is equal to 10. Let's look at the possible ways of getting 10. To get 10, we are going to have, now we have seen that the die, we have 3 dice, or a die is rolled thrice. The total possible outcome is 6 raised to the power 3. 6 times 6 times 6. Now, the possible arrangement to get 10, we have 136, 145, 226, 235, 334, 442. So let's look at the total possible arrangement that can come out of this combination, or yes, of this mix. So we have 136. So here we are going to have 3 P 3. Here the same thing, 3 P 3. Here we have 3 P 3 over 2 factorial. Why? 2 and 2. We have 2. Here we also have 3 P 3. Here we have 3 P 3 over 2 factorial. And why? We have 2 3's. Here also we have 3 P 3 over 2 factorial. Why? We have 2 4's. Now let's get the answers. Here is 6. Same thing here. Here we are going to have 3. Here we are going to have 6. Here we are going to have 3. Here we are going to have 3. So what is the total? This is 15. And this is 12. So everything is 27. So probability of getting 10 is equal to 27 over 6 times 6 times 6. And what does that give us? 3s 9. Here is 2. 3 and 3 1 over 8. So you can see, very simple and direct way of handling the situation. 12 chairs in 2 colors are arranged as shown. Find how many ways 9 people can sit on the chairs. If 2 blue shares in column C must remain unoccupied. This one. All the green shares must be occupied. This one. C. More blue shares must be occupied. We'll get to that. At least one of the shares in row 2 must remain unoccupied from this one. Now let's look at the conditions. A. It says the 2 blue shares in column C must remain unoccupied. What does that mean? It means these ones are not part of the arrangement. So we have 10 shares remaining. That is 12 less 2. We have 10 shares remaining now. And in these 10 shares, we are going to arrange 9 people. How many possible arrangements do we have now? So, total possible arrangements will be equal to 10p9. Straightforward. It now says all the green shares must be occupied. What does that mean? B. How many green shares do we have? We have 6. 6 green shares. So, what does that mean? It means that for these green shares, we are going to have, since it must be filled, we have 9 p6, sorry. 9 p6. Now, to arrange, since it must be filled, we must give it priority. That's 9 p6. Now, for the remaining 6 shares, after these 6 chairs have been filled, we have 3 people left. So the number of ways to arrange the 3 people in the 6 remaining chairs. To arrange the 3 remaining people will be equal to 6p3. Therefore, total possible arrangements will be equal to 9p6 times 6p3. That's why I need to work that out. So, that is 7,257,600 number of possible arrangements. Now, the third one says, more blue shares must be occupied, which means that we are going to arrange the 9 people to occupy more blue shares than more green shares. Let's see how it will be. Now, let's look at it. If we are going to have more blue shares to be occupied, we have 6 green and 6 blue. So if we want to have more blue shares, the arrangement will be blue, green. So, which means that we can either have 6 blue shares and then we are going to have 6 green shares, or we are going to have 5 blue shares, 4 green shares. But if you have anything less than this, it will not be giving us the condition as in the question. So 5 and 4. Now let's see how we can have it in this place. Now, if we are going to have 6 blue and 3 green, the arrangement is going to be 6 blue, 3 green. It's going to be 9p6 times 6p, as in the second question. Now, for this one, for 5 blue shares and 4 green shares, for this 5 now, we can select the 5 in different ways from the 6 shares. That is, we are going to have 6. That is it. Now, how do we fill this 5? We are going to fill it by 9 permutation 5. We are now going to have 4 remaining. These 4 will now be arranged in the 6 remaining green chairs. And how do we find that? It's going to be 6p4. Now, let's look at what the total will be. So now, after solving, this is the total answer. 39,916,800 number of arrangements. That is for the C part. Let's look at the last part. Now for this part, it says, at least one of the chairs in row 2 must remain unoccupied. And you can see, how many do we have in row 2? We have 4. If all, what is the total possible arrangement? Total possible arrangements overall is equal to P9. Now, if all this place, we have all of them occupied, what does that mean? Are occupied. Number of arrangements will be equal to 9P4. You know, the 9 for this place. We are now, after that, we are going to have 8 chairs in which we are going to distribute the remaining 5. That is 8P5. This is for the 4 of this one. And this is for the arrangement for the remaining 8 chairs. Remaining 8 shares. This is for the 4 shares in row 2. So, if we have this, total for at least one share to remain unoccupied, what does that mean? It means that at least one of the shares to remain unoccupied is equal to total possible arrangements minus all the chairs in row 2 are occupied. What does that? That is what we have. 12P9 minus this. So we have 59,512.32. Another way you can look at it is this. Now it says at least one of the chairs in row 2 must remain unoccupied. That is, we can have 2 occupied, 3 occupied, and 1 occupied. Sorry. And what does that mean? It means that all the 4 cannot be occupied. Now, because we have 2 to be occupied in the row, we can select the 2 to be occupied in 4C2. Now, since we have it that way, we are going to have 9P2 to fill the 2. Then we are going to have remaining 7 for the other remaining 4C2, 9P2 for the remaining 8 places. So what does that give us? Times 8P7. So what does that? I hope you understand. For this place, we have handled all this place with this. It remains this place and this place. For the third one too, how many ways can we select 3 shares? We have 4C3. But these 3 can be filled by 9P3. It still remains 8 again. Since we have selected 3 out of the 9, we are going to have 8P6. Now, if we are going to have 1, it says at least 1, which means 1, 2 can be occupied. We have 4C1 times 9P1. Now, what remains? We have 8 shares. 8P8. Now, let's solve this one too. I hope you understand. This is the number of ways we can select the shares. But this is how we can fill the 2 shares. Then this is the way we can fill the remaining 8 shares. Remaining 8 shares. You know, this is just for the middle. This is for the remaining up and down 8 shares. Now let's do the calculation. So you can see the answer when you use the alternative way, alternative method of handling it. You can see. Now let's go to that. There are only green pens and blue pens in the box. There are 3 more blue pens than green pens in the box. There are more than 12 pens in the box. Simon is going to take at random 2 pens from the box. The probability that Simon will take 2 pens of the same color is 27/55. Work out the number of green pens in the box. So let's look at the information given to us. So we are told that the total number of pens in the box are green, that is the only colors, and blue. And we are told that the number of blue is 3 more than green. So blue equals green plus 3. And we are told that there are more than 12 pens in the box. So n is greater than 12. The probability that Simon will take 2 pens and the same color is 27/55. So what does that say? It is saying that, so if you use the tree diagram, so GB. So we are going to have GG. So here we are going to have GB. So we are going to have B, B2. Because it is taken at random, one after the other, we are going to have a condition, independent probability. So that's the situation we are going to have. So if you look at this one, we are going to have G1, G2, B1, G2. So for the same column, we are going to have this. So for same column, it's going to be P, G1, G2 plus probability of B1. So everything is now clear for us. And we are told that this one is equal to 27 over 55. So we have to find the number of green pens in the box. Now let's make everything in terms of G. We have made blue in terms of G. Let's make N in terms of G. N will be equal to G plus 3, which is 2G plus 3. Now, let's find PGG. That is probability that we are going to have green colors only. So P is going to be G over 2G plus 3 multiplied by G minus 1 over 2G plus 2. You know why? When we are picking the second green color, we are going to have this one less by 1, and this one too will be less by 1. That's why we have it like this. So for P, B, B, we are going to have, what is our initial B? So the two belong. G plus 3 over 2G plus 3 times G plus 2 over 2G plus 2. Because this one will be less by 1, this one will be less by 1. Now let's work it out. So we are going to have G squared minus G over 4G squared plus 10G plus 6. In the same way, we are going to have G squared here plus 5G plus 6 divided by 4G squared plus 10G plus 6. So the addition of these two is going to give us 27 over 55, you see. So we are going to have P, G1, G2 plus P. So if we had, we are going to have 2G squared plus 4G plus 6. The denominator is the same, 4G squared plus 10G plus 6. So by the time if you see 2 is common, we can divide both by 2, G squared plus 2G plus 3 over 2G squared plus 5G plus 3. And this one is equal to 27 over 55. You can see. So, checking this, you will see that this will be 55G squared plus 110G plus 165G is equal to 54G squared plus 135, yeah, G plus 81. Now, let's gather the like to one side. Let's gather everything to one side. So subtract this one from here. We are going to have G squared minus 25G plus 84. Oh, this one, there's no G here, please. Plus 84 is equal to 0. Please note, there's no G here. So, factorizing, we have G squared minus 4G minus 21G plus 84 equals 0. So we have G into G minus 4 minus 21 into G minus 4. So G minus 21 into G minus 4 is equal to 0. So G will be equal to 21 of 4. So if we have G to be this, B, that is blue, will either be equal to 24 or 4 plus 3, which is 7. B equals G plus 3. Note. So you can see. But from the question, we are told that the total pen is equal to more than 12. If you take green to be 4 and blue to be 7, which means that we won't have up to 12. So the right value for green is equal to 21 pence. Because if you add these two, it won't be up to 12. That is it. Now you can confirm if our answer is correct. Let's check. Now, on checking the answer, it will be 21 over 45 times 20 over 44, because the total number is 45, plus 24 over 45 times 23 over 44. So at the end of the day, I confirm everything to be 27 over 55, which means our answer is correct. Seats for the guests at an award ceremony are arranged in 2 rows of 8 and 10, divided by an arrow as shown. Seats are randomly allocated to 18 guests. Find the probability that 2 particular guests are allocated seats, A or 1 in the same side of the arrow, 2 on the same row, 3 on the same side of the arrow and in the same row. So you can look at it from two different ways. So we look at least the 2 common ways of perceiving this. Now we are told that we have 18 guests and we have 18 chairs to allocate to them. But we are concerned about 2 particular guests. And we are trying to find the probability that the 2 guests are allocated seats on the same side of the arrow. Now let's look at it. For these 2 guests, they can be given seats they can sit in any order. So the total possible order the 2 guests can sit is equal to 18 pt. That is, the 2 of them can sit in any arrangement. The total will be 18 pt. Now, if they sit on the same side of the arrow, that is, the 2 of them sit here, or the 2 of them sit here. When they get here, they can sit in any order in these 9 seats and in these 9 seats. So, 1. The total possible order for the 2 guests to sit on the same side. Since they are going to fill all the chairs, we don't need to disturb ourselves about selecting. So it means that for this side, it will be equal to 9 permutation 2. And on this side, it's going to be 9 permutation 2, which is 2 times 9 permutation 2. Therefore, the probability that the seats on the same side is equal to 2 times 9 p2 divided by 18 p2. And by the time you look at it, it's going to be 2 times 9 times 8 divided by 18 times 17. So that's going to give us 8 over 17. Or, let me see. So I got 0.4706. Now let's check the other one. Now, if we are going to check if they are going to sit on the same row, that is, we are considering this part and this part. That is, to sit on same row. If they sit on the first row, the total possible arrangement is going to be first row 8 p2, second row is 10 p2. So total probability of sitting on same row will be equal to 8 p2 plus 10 p2 divided by 18 p2. So that's going to give us 8 times 7 plus 10 times 9 divided by 18 times 17. And this is going to give me, okay, I can still divide 2. 4, 5, 9. So this is 28 plus 45 divided by 9 times 17. Equal to 73 over 153, which gives me 0.4771. So you can see. So the last one says on the same side of the arrow and in the same row, which means that we have to consider it like the 2 of them must be here here, here, or here. So we are going to look at it from 4 divisions. From 4 divisions. This is the total possible arrangement for them. Now, so on the first row, right side. First row, left side. Second row, right side. Second row, left side. So what does that give us? For the first one, we are going to have 4 P2. The second one, we are going to have 4 P2. That is the arrangement for the 2 of them in the 4 seats. The second row, first side, is 5 P2. Here we have 5 P2 as well. So the total is going to give us 2 into 4 P2 plus 5 P2. And then the probability of being on the same row and side at the same time is going to be 2 into 4 P2 plus 5 P2 over 18 P2. And that will give us 2 into 4 times 3 plus 5 times 4 over 18 times 17. Let's see what that one totals. This is 12, this is 20, 32. That is 64 over 18 times 17. If I divide this one by 2, that gives me 32 over 9 times 17, which is 32 over 153 over 18 times 17. So on the divide I have 32 over 9 times, which is 32 over 153. And the answer is 0.2092. So you can see it's very simple and straightforward, depending on the way you look at it. Another way you can look at it is this. In this instance, you are looking at all of them, not only the 2 particular guests. For the arrangement of all of them, total possible arrangements of all the guests, of all guests, will be equal to 18 P18. That's 18 factorial. Now, if we have 2 particular guests on the same side, that is, they can either be here or here, the 2 of them. But when the 2 of them have occupied the seats they are given, the 16 other guests will now have opportunity to be arranged in any order. So let us assume that the 2 guests are on this side. In how many ways can there be allocated seats on this side? Let's see. The 2 guests on the right side, since they are just 2, we can arrange any 2 seats for them. Any 2 of the seats we can pick for them, and that will be 9C2. You can see. And after you have picked this 9C2 for them, they can sit in the seat in any order of 2P2. Anyhow they like, they can sit on the seat. Then the other 16 can now sit in 16P16. That is on the right side. You understand? If the 2 guests are on the left side, it will be the same thing. 9 select 2 times 2P2 times, what's it? 16 is 16. So the probability will be equal to 2 times 9C2 times 2P2 times 16P16 divided by 18P18. So let's see what it will give us. By the time you look at this one is going to give us 9 permutation 2, the combination of this. Anyway, let's continue. So it's going to be 2 times 9C2, that's 9 times 8, okay, let's just leave it, 9c2 times 2p2. This is the addition of this, please, times 16p16 over 18p18. This one from this will give us 18 times 17, please. So, are you able to 2 times 72 over 18 times 17. So here I have 9 here. So this one called this 8. So I have 8 over 17. Just like we got it earlier on. You can consider it like this, or you can just segment it to the only 2 guests. Let's look at the second one. How do we look at it? Now, in the same row, that is either on the top or below. So for the first row, if the 2 are on the first row, the way to arrange all of them is going to be 8c2 times 2p2. That is for the 2 alone. Then, how do we arrange the other 16? It's going to be 16, p16. The 2 of them on the second row will be 10c2 times 2p2 times 16, p16. So, probability now will be equal to 2p2 times 16p into 8c2 plus 10c2 over 18p18. So you know that 2p2 is 2 already. We could have done it straight, but just to simplify it, this will give us 18 times 17. What's 2p2? 2. 8. What's 8c2? Let's work it out. So you can see 2 in 18 9, and then 8c2 is 28, 10c2 is 45, and then you can see we got the same answer. The reason I'm showing you this is for you to know that nobody has the monopoly of how to handle any combination, permutation, probability. You can view it from any angle. And if you have any other better way of doing it, you can comment, you can send it to me as assistance or help, and for other people to learn from it. In the same way, you will do the third one. Let's see how that one goes. For this one now, you have 4 divisions. First row, right side. First row, left side. That's the left hand side. Second row, right hand side. Second row, left hand side. So if you look at it, for this first row, right hand side, we are going to have 4c2 times 2p2 multiplied by 16p16, because the 2 will select 2 of the 4 seats, and then the other will select the remaining seats. Same thing here, 4c2 times 2p2 times 16p16. So here we have 5c2 times 2p2 times 16p16. Again, so total arrangement is going to be 2 times 2p2 times 16p16 into 4c2 plus 5c2. So you see, it is very simple now. Now let's work out our probability. Probability of sitting on same side and row is equal to 2 times 2p2 times 16p16 into 4c2 plus 5c2 over 18p18. Now, we know that once we cut this, is going to give us 18 times 17. 2, this one is 2, this one is 2. Okay, let me use this one. So this one will give us 9. So we are going to have 2 into 4c2 plus 5c2 over 9 times 17. I hope you understand how I did the cut. So that's it. This one gives me 18 times 17. From here, I cut this one, gives me 9. So, let's see. So, you can see. It is simplified already. That's all.